All right, in this video, I'm going to go over how to use L'Hopital's rule. And L'Hopital's rule is going to be used to find a limit. And we're going to use it to find limits when we have indeterminate form or we have plus or minus infinity divided by plus or minus infinity. And we usually introduce this after the unit on limits and after we learn the derivative because you're going to need derivative in order to do this. All right, so before we do some L'Hopital examples, let's just look at problems that we could use L'Hopital's rule on. So for example, in the first one here, if I would plug in 2 by direct substitution, I would get 0 divided by 0. We have learned other methods of solving this limit by factoring, which could easily get this limit, but we're going to show you how this could be done with L'Hopital's rule. Same thing with the next example here. We have a limit at infinity that has a power of 2, and this would be negative infinity divided by infinity, which could be done with L'Hopital's rule. So if we weren't using L'Hopital's rule here in this first one, we would get the limit as x approaches 2, and we would get 1 over x plus 2, which would equal, now we can use direct substitution and plug in 2, and we would get 1/4. Okay? In the second example, we can see the fact that the highest power is 2, and it's the same in the numerator and the denominator, so the limit here would be divided the coefficients, and we would get negative 5/3. Well, what about what is L'Hopital's rule? So in L'Hopital's rule, what we're going to do is we're going to take the derivative of the top and the bottom separately, and then try to plug in our value and see if we get an answer. If that doesn't work, we repeat the process. Okay, so let's look at this same example with L'Hopital's rule. Okay, so L'Hopital rule states that if we have the limit as x approaches a of f of x over g of x, and we get indeterminate form 0 over 0, or plus or minus infinity over plus or minus infinity, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime x over g prime x. And we could also continue that process until we can get a limit. So since we have indeterminate form and in an infinity over infinity, both of these problems can be done with L'Hopital's rule. And what we're going to do is we're going to take the limit, or I'm sorry, we're going to take the derivative of the top and the bottom. So in this problem here, what we're going to do is we're going to say this is the same thing as the limit as x approaches 2, and we're going to take the derivative of the top with respect to x, so that would be 1, and the limit of the derivative of the bottom with respect to x is 2x. Now we try to use direct substitution, and we can, and we get the same answer as what we did in the previous, 1/4. Okay, same thing with the next problem. We're going to take the derivative with respect to x, top and bottom. Now we're not doing the quotient rule, we're doing the individual derivatives of the top and bottom. So the top would be negative 4 minus 10x, and the bottom would be 6x minus 1. Now, if we look at this here, if we plug in infinity, we're still going to get negative infinity over infinity. So it's still in a form that we can't see the answer. So again, we do the same thing. We take the derivative of the top and bottom. We continue with that. So we say the limit as x approaches infinity. And we're going to say the derivative of the top now would be negative 10. And the bottom would be 6, and since it's a constant, we have our limit, so the answer is negative 5/3. Okay, now those two problems, we probably didn't need to use L'Hopital's rule. So in the next example, I'm going to show you where you definitely need L'Hopital's rule and when it's used on the AP. Okay. Okay, let's do some examples with L'Hopital's rule. So you're gonna look for limits that have some type of transcendental function mixed with a polynomial. So for example, I see the cosine of x on the top and I have a polynomial in the denominator, and same thing here, I've got e to the negative x in the denominator. These are the type of problems you're going to want to use L'Hopital's on, because you're not going to be able to use some of the techniques you learn with limits, such as factoring and horizontal asymptotes and things like that. So the first thing we need to check is see if we get 0 over 0 or an infinity over an infinity. So if I plug in x equals 0 here, I get cosine of 0, which is 1, minus 1 is 0, divided by, plug in x equals 0, I get 0 over 0. So I can use L'Hopital's rule here. So the limit as x approaches 0, the derivative of cosine x is negative sine x, the derivative of negative 1 is 0, divided by 2x minus 1. Now I try to plug in 0, and I would get negative sine 0, which is 0, and I would get negative 1 on the bottom, and that comes out equal to 0. Okay, next example, if I go to plug in negative infinity into the numerator, I would get negative infinity squared. I'd get infinity over infinity, so I can use L'Hopital's rule here. So this would be the same as the limit as x approaches negative infinity of the derivative of the top is 2x, and the derivative of the bottom is a chain. It would be negative e to the negative x. I try to plug in negative infinity, and I'm going to get negative infinity over negative infinity. So I have to continue with this process. So I'm going to take the derivative again, and I would get 2 in the numerator, and I would get positive e to the negative x. Now, if I do this, since I have the constant on top, and the bottom is going to grow as negative infinity gets plugged in here, it's going to be bottom heavy, so my answer would be 0. All right, in our last example, we can see that we have a natural log x in the numerator and an e to the x in the denominator. So this would be an example of trying to use L'Hopital's rule. So we're going to plug in 1 by direct substitution, and we get natural log of 1 minus 1 plus 1, all divided by e to the first minus e, and this is 0 over 0. So L'Hopital's rule applies here. So let's take the derivative of the top and the bottom and try the limit. Okay, so the derivative of the top would be 1 over x minus 1. The derivative of the denominator would be e to the x minus e. We're going to try direct substitution again. We'd get 1 minus 1 divided by e minus e, which gives us 0 over 0. So we're going to repeat the process, take the derivative again as x approaches 1. The derivative of 1 over x would be negative 1 over x squared. The derivative of negative 1 is 0. The derivative of e to the x is e to the x, and the derivative of the constant e is 0. So now we try to plug in x equal 1, we would get negative 1 over e as our solution. All right, so that was an introduction to L'Hopital's rule. I hope that was helpful for you. So please like and subscribe. Thank you for watching.